Okay.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. We are a representative of Group 5. Would like to present Chapter 17 of the Operation Management, which is about the maintenance and reliability. We are Group 5. Would like to introduce ourselves. My name is Afif Akbar Hibibi, and alongside me are my members, which are Rahmat Rifaldo, Rafika Hamina Himdi, Putri Samina Ferza, Raisa, Aditya Wahyu Gunawan, Muhammad Ahlam, and Gina Maria Harun. Next slide, please. Right. So the first learning objective that we have to know is actually the how to improve system maintenance. So in order to improve the system maintenance itself, we need to know what is the maintenance itself in the very first place. Maintenance is actually a way for people to a way for companies or firms to actually fix their to prevent the kind of things to happen within their machines. For example, how they take care of the machines and etc. And one way for them to do that is actually by employee involvement. What kind of employee involvement we are talking about in here are actually the autonomous maintenance partnering with the maintenance personnel, skill training, reward system, employee empowerment, continuous improvement. Those are the criteria of the employee improvement. And then thus, actually, the maintenance and reliability procedures becomes the clean and lubricate, monitor and adjust, make minor repairs, and keep accurate records. So these are the activities that is happening towards the machine by the employee itself. And as a result, it actually reduce the variability, reduce inventory, improve quality, improve capacity, protecting investment in plant and equipment. So one way for us to actually improve the system maintenance is actually by creating a maintenance reliability procedures using several tactics later on. And also, this will actually yield into an enhanced productivity, winning products, and improve profitability. Next slide, please.
Okay, for this slide, determine the system reliability. For example is reliability in a service. The National Bank of Greeley, Colorado processed loan application through 3 clerks, each checking different sections of the application in series, with reliabilities of 0.9, 0.8, and 0.99. It wants to find the system reliability. For the approach is like we could see this, R1 is 0.9, and then comes to R2 0.8, next to R3 0.99. And that's all the system reliability RS. The solution is, so the reliability of the loan process is RS equal with R1 multiplied by R2 multiplied by R3, and then equal to 0.9 multiply 0.8 multiply by 0.99, and the result is 0.713 or 71.3%. For the insight, since each clerk in series is less than ideal, the error probabilities are combined, and the resultant reliability for this series is 0.713, which is worse than the reliability of each individual clerk. And next.
Okay, next learning objective 3 about determine mean time between failures and redundancy. Mean time between failures or MTBF is the expected time a repair and the next failures of a component, machine, process, or product. The basic unit of measure for reliability is the product failures rate or FR. So the equation to get the value of failure rate measure the percent of failures among the total number of product tested, or FR% equals number of failures divided with number of unit tested times 100%. And the question to get value of a number of failures during a period of operating time, or FRN, equals number of failures divided with number of unit hours of operating times. Last, the equation to get value of MTBF is 1 divided with FRN. So in order to better understand, we see an example from MTBF. 20-hour conditioning system designed for use by astronauts in Russia's Sayar space were operated for 1,000 hours and the Russian test facility. Two of the systems failed during the test, one after 200 hours and the other after 600 hours. The approach to determine the percent of failures, the number of failures per unit of time, and the mean time between failures. We use equation 17.2, 17.3, and 17.4. Next slide, please. The solution is percentage of failures, or FR percent equals number of failures divided with number of unit tested times 100% equals 2 divided 20 times 100%. The result is 10%. Number of failures per operating hours, or FRN, equals number of failures divided with number of unit hours of operating time, where total time equals 1,000 hours times 20 units. The result is 20,000 unit hours. Non-operating time equals 800 hours for first failures times plus 400 hours for second failures. The result is 1,200 unit hours. Number of unit hours of operating time equals total time minus non-operating time. FRN equals 2 divided 20,000 minus 1,200 equals 2 divided 18,800. The result is 0.000106 failures per unit hours. Because MTBF equals 1 divided with FRN, so the MTBF equals 1 divided with 0.00106. The result is 9.424 hours. If the typical size shuttle trip to the International Space Station lasts 6 days, Russia may note that the failures rate per trip is the failures rate equals failures per unit hours times 24 hours per day times 6 days per trip equals 0.00106 times 24 times 6. The result is 0.0153 failures per trip. The insight is mean time between failures of, or MTBF, is the standard means of stating reliability. Okay, that's all for me. The next.
Okay, redundancy. Redundancy is added in the form of backup components or parallel paths. The redundancy is provided to ensure that if one component or path, the system has recourse to another. Backup redundancy. Assume the reliability of component is 0.8 and we back it up with another component with a reliability of 0.75. Resulting reliability is probability of the first component working plus the probability of the backup component working multiplied by the parallel redundancy. Another way to enhance reliability is to provide parallel paths. In a parallel system, the paths are one page allow the system to perform. Okay, this for AO3. Next.
Distinguish between preventive and breakdown maintenance. Preventive maintenance and breakdown maintenance are the cornerstone of any professional maintenance program. One might even say they are the most commonly used maintenance strategy on the plants. However, the reality is most maintenance teams really upon a mixture of preventive and breakdown maintenance to achieve their goal. One, preventive maintenance. Preventive maintenance refers to maintenance tasks that are revolved on a repeated schedule of schedule to prevent failure. These tasks include conducting regular inspecting, reporting indicated equipment issue, and replacing part before failure. Preventive maintenance improves identifying triggers that indicate potential equipment failure. There are 5 different types of preventive maintenance, which include 1. Risk-based maintenance. Refer to maintenance tasks that are referred depending on level of risk and asset posed in the event of failure. 2. Failure finding maintenance. This type of preventive maintenance focus on detecting potential hidden failure of assets that reform protective. 3. Time-based maintenance. Refer to maintenance tasks that are reformed at which involve regardless of the asset condition. 4. Condition-based maintenance. Focus on a piece of equipment that is in the process of failing or indicating an impending failure. 5. Predictive maintenance is a more advanced form of CBM that use process parameter to determine whether an asset is headed toward failure. The different type of preventive maintenance strategy all hold the same goal. Performance maintenance takes before failure occurs. Next. 2. Breakdown maintenance. Breakdown maintenance, also referred to as corrective maintenance, is a strategy that perform maintenance tasks only after an asset fails. Maintenance tasks are only performed when they become urgent, for example, repairing or replacing a water heater after it has broken down. Type of redundant maintenance. Redundant maintenance is also referred to as run to failure maintenance. As the name suggests, involves performing maintenance tasks after an asset has failed. It is most often used when preventive failure is impossible or not economical failure. There are 2 types of breakdown maintenance. 1. Planned breakdown maintenance. In this instead, an organization anticipates a specific type of equipment malfunction in the near future. 2. Unplanned breakdown maintenance. Every facility on the planet is familiar with unplanned downtime. It is worth maintaining that breakdown maintenance is often confused with corrective maintenance. Though the terms appear similar, they are not the same. That's all for me. Thank you. Next.
How to improve the maintenance? Reliability and maintenance are such of importance that most maintenance management systems are not computerized. The major components of the systems with files is to be maintained on the left. The reports on the left and the reports are generated on the right. Example, companies from Boeing to Ford are improving product reliability via their maintenance information systems. Boeing company monitors the health of their planes in flight by relaying relevant information in real time to the ground. This provides a head start on reliability and maintenance issues. Similarly, With a wireless satellite service, millions of car owners are alerted to thousands of diagnostic issues, from faulty airbag sensors to the need for an oil change. These are real-time systems provide immediate data that are used to head off quality issues before customers even notice the problem. The technology enhance reliability and customer satisfaction and catching problems early to save millions of dollars in warranty costs.
All right, as for the LO6, comparing the preventive and breakdown maintenance. So one example of question is that there is a printing company that actually have a number of breakdown for a period of time. So in here, we've seen that on the data, it is provided that there are 20 totals of month which the breakdowns occurred. And then the total of breakdown happens within that period of month is as following. So what we have to do first in order to search and compare the preventive and breakdown maintenance is that we have to know the frequency of each expected number of breakdowns. This can actually be calculated by calculating the number of breakdown times it with the frequency. So for example, on the number of breakdown for the first 2 months would be 0, as it is 0 times 2 divided by 20. Go and so forth with the next one. So at the end of the this, we can actually see that the expected number of breakdowns would calculate it to 0 plus 0.4 plus 0.6 plus 0.6, which involves with the 1.6 breakdowns per month. So these are the number of breakdowns that occurs within 1 month. Next slide, please. Next, when we want to actually compare between preventive and breakdown maintenance, which one is better? First, we search the expected breakdown cost first. On the example known, we know that the cost per breakdown is actually $300 since it is the thing that we actually purchased. So we know that the expected breakdown cost before was 1.6 as the previous one we searched before. And then after that, we times that by the cost per breakdown, which is $300. Which at a total will get $480 per month in expected breakdown cost. Comparing that to the preventive maintenance cost, where we calculate that by cost of expected breakdowns if service contract is signed, plus the cost of service contract. So how much is the cost of expected contract itself? We know that it is the $300 plus 1 breakdown per month. Plus, and then you add that with the cost of service contract, which is known in the example, which is $150 per month. Therefore, you add that, an additional of that is $450 per month. We know that the expected breakdown cost is actually way more than the preventive maintenance cost. So the conclusion that we can actually draw in here is that because it is less expensive overall to hire a maintenance service firm, which is less expensive, $450, then to do so, it is better to not hire it is actually better for the company to hire the service firm, as it is better to prevent that. We can save over $30 per month in the preventive actions. That is all. Thank you.
Okay, I will explain about autonomous maintenance. Basically, autonomous maintenance is a preventive maintenance policies and techniques must include and emphasize on employees, accepting responsibility for the observe, check, adjust, clean, and notify type of equipment maintenance. Such policies are consistent with the advantage of employee empowerment. This training will ensure that operators' skill increase. It will teach them what they need to know and possibly even empower them to improve the equipment with time. Operators are taught basic maintenance tasks with a focus on being proactive and responsive to machine problems. Those facilitating these training sessions will mainly be maintenance technicians and engineers. Every operator will inspect and maintain their piece of equipment. Plus, technical training will prepare them to notice any change and troubleshoot them quickly. Typically, they will learn equipment cleaning, inspection, lubrication, adjustment, quick repairs, identifying signs of deterioration, safety, and when they need to involve maintenance staff. Here we can see in the figure is that preventive maintenance costs less and faster the more to the left, it will increase operator ownership. and competence is higher as it is moved to the right, it will increase the complexity. Next slide, please. How to implement autonomous maintenance. First is to increase operator knowledge. This involves training from maintenance technicians on the technical details of how the machine's component work and their purpose, as well as training on problem-solving skills. Second is initial machine and cleaning inspection. This step is where equipment is returned to a baseline state with the goal of getting it back to a like-new condition. Third, remove the cause of the contamination and improve access. 4 is develop standards for lubrication and inspection. 5, inspection and monitoring. 6, standardized visual maintenance. And the last one, continuous improvement. Okay, that's all from me. Next.
So therefore, everyone, we can conclude that operation manager focus on design improvement, backup components, and parallel path to improve reliability. Reliability improvement also can be obtained through the use of preventive maintenance and excellent repair facilities. Firm give employees ownership of their equipment. When workers repair or do preventive maintenance on their own machines, breakdowns are less common. Well-trained and empowered employees ensure a reliable system through preventive maintenance. In turn, the reliable, well-maintained equipment not only provides higher utilization, but also improve quality and performance to schedule. Top firm build and maintain system that drive out variability so that customer can rely on products and service to be produced to specification and on time. Thank you. That's all from me.
All right, so that is all for our presentation, everyone, the Group 5 presentation regarding the reliable and also the maintenance. So we've explained from the learning objective 1 until learning objective 7 and even summarize it to you guys. So what we like to do is that we would like to help a Q&A session, but we will all very prioritize those who have not asked question yet. So within the list that will be given later on the group WhatsApp chat, those who already included their name cannot be asking questions towards our presentation because we will be prioritizing those who haven't answered, who haven't asked a question yet. So that is all for our presentation, everyone. Thank you very much, and hope that you will understand what the materials of our Group 5 have been explaining to you. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.